series, adding terms up from n equals 0 to infinity. We're trying to see if this adds up to a finite amount or does the total equal infinity. Using the integral test basically says this: if you have n equals 0 and then 1, 2, etc., and you plug those values into this rational function over here, we would get a value of 1, and then 1 over 2, 1 over 3, 1 over 4, etc. Now technically what you're supposed to do is add up these fractions, 1 and a half and a third and a quarter, and see if the total is finite or infinite. Well, what we could also do is say, well, if we estimate that there's a rectangle right here at a height of 1 and have this delta x width be 1, then the area of the rectangle is the same thing as the height, which is 1. So in other words, right here, instead of adding up a 1 and a half and a third and a quarter, I could add up the area of these rectangles. The area of this rectangle is 1, and then a half, and a third, and a quarter, etc. Then, instead of adding up rectangles, we were to integrate underneath this function 1 over n plus 1, n plus 1, well, then that would be finding this area. Since the area of the rectangles is very, very close to the area of this, then if we get a finite result, we can be pretty confident that this adds up to a finite amount. If the total red area adds up to infinity, then this series here will add up to infinity. So we just integrate, and you could use n if you want to. I'm going to use x. So add up as x goes from 0 to infinity. And then this is much like 1 over x. It's going to be natural log, but it'll be a natural log of x plus 1, evaluated 0 to infinity. So when you substitute infinity, that's going to say natural log of infinity. Technically, you're supposed to say the limit as x approaches infinity, but we can shorthand it here with natural log of infinity. Or in other words, what's happening to the natural log function as x goes off to infinity. Then substitute a 0, so it's going to be natural log of 0 plus 1. So the natural log function looks like this. As x goes to the right forever, or in other words, as x goes to infinity, what does the natural log function do? It goes up and up and up. It doesn't do it very quickly, which is an important point in this chapter, but it does go to infinity. So that means this is going to be infinity. This is 0. Natural log of 1 is 0. So that means that the answer is infinity. So the answer to this then is that the series diverges. Therefore, the series is going to add up to infinity, or in other words, diverges. You could also estimate that if you use the calculator and go sum sequence. Hey, that's not sum. Sum, the sequence, the function is 1 divided by, I'll use x plus 1, as x goes from 0 to, and then pick some large number. Well, I guess I could start with 100. So with that, it's 5.197, and then if you add up 1,000 terms, come on, calculator, you can do it. No, I guess you can't. How about 990 terms? So last time it was 5.1 something when I added up 100 terms. When I add up 990 terms, it's jumped up to 7.4. So it jumped from a 5.1 to a 7.4 when I added an additional 890 terms. So this is what I was saying earlier. It's going to infinity, so it jumped from 5.1 to 7.4, but it's going very slowly. That's this idea. Natural log does go to infinity, but it really takes its time getting there.